All right, so today we're going to continue our discussion from our previous section, which was talking about internal forces and how they change as we go through the structure. So shear and moment diagrams are going to be how we show this visually. So we're going to talk about how this internal force changes with location. We're going to hit on that again. We're also going to talk about how we can use our free body diagrams to create simple shear and moment diagrams. And we're going to practice that force convention some more to make sure that we really understand it. All right, we're going to start today, and most of our shear and moment diagrams today are going to be focused on beams. Now, beams are found in almost every structural application. This works for what I used to do as far as building, as dealing with buildings, but we're also going to see it in structural applications like this airplane wing. If you remove the skin on a lot of airplanes, you're going to see structures like this. They call this a spar. The center member is called a spar, and then we call these members that come off of it a rib. And these ribs and these spars act just like our beams in, buildings. Basically, here we have our girder, and here we have our beams coming off the sides. Same idea. We've got a spar going down the middle, carrying most of the load that's being transferred from these ribs. Now, the nice thing about beams is we basically have three different types of beams. You're going to see these beams used almost everywhere. The most common one you might recognize, we've used it a few times, is a simply supported beam, right? A simply supported beam has a pin over here and a roller right here. The other beam that we've seen a lot of times before is the cantilever. This means, hey, we've got a fixed connection on this end and a free connection over here. And an overhang is somewhere in between, where we have a pin at one end, a roller in the middle, and then kind of this overhang on one side. Let's see some examples of this in real life. Very simple example of a simple connection is these sort of middle beams right here that are going from column to column. And if you notice, it's hard to see, but if you look really closely right there, you're actually going to see, if this is our column, let's draw that again. If this is our column, and we have our classic I-beam shape, I'm exaggerating this a little bit. To that column, we have this bracket that's welded here, and there's some bolts. We'll just draw 2 bolts here, but you can see in this particular problem, there's 3. And there's an air gap that I've exaggerated a lot here. And the thing about these bolts is when we bolt this, because we're basically lifting a big heavy object, somebody's got to crane this thing in here, right? And there's somebody hanging on the side of this building, or hanging on the side of this column trying to bolt this in, get these bolts. There's usually a little bit of tolerance or slop in that. So if you take kind of a close-up of that connection, our bolt may be this big, our hole might be this big, but our bolt shank is actually probably about that size with a big old head on the end of it, right? Which means these things can rock a little bit. We're gonna see this thing rock this way. Well, let me do it more like this. Rock this way a little bit. So in this particular case, even though it might look a little bit fixed, we're actually going to assume that on this end, we've got a pin connection on the other side. We're only going to rely on these sorts of connections like this, these sorts of reactions. So that's a good example of a simple connection, even though it doesn't look like one. Here's a great example of a cantilever. We see cantilevers all the time because we love balconies. Balconies are money makers. If you have a balcony, you have so much space, you've got a view of outside. It makes it seem like even if you're living in a tiny, 600 square foot apartment, even if you got a 600 square foot apartment, this balcony makes it seem like you're living in a much bigger space, even if you only step out onto it twice, which I find that was my experience living in any place with a balcony. I'd walk out on it maybe twice a year, tops. So these sorts of things, we see this pretty common. Here is a cantilever, and you can see it kind of carries through there. Now this looks, it's kind of fixed right here, right? And you can actually see, let me erase some of the things that I've just put in there. You can see that this is actually welded in there. It's actually welded right there.